Hi everyone, and welcome back to a new lesson on IB Math. In today's lesson we will be studying regression lines and Pearson's correlation coefficient R, which is a topic in all IB Math programs, IB Math AA and AI, standard level and high level. And of course I will show you how to get the value of the Pearson's correlation coefficient R and the equation of the regression line step by step in your GDC. So first, what is correlation? Correlation tells us if there is a relationship between two variables, x and y. It tells us if they are correlated or not. X could be, for example, the number of hours we study, and y would be our score in an exam. Are they correlated or not? And even if they are correlated, how strong that correlation would be. So here, as you see, in these graphs, we have positive correlation. Positive because if we graph the line of best fit or the regression line, as you see, it has a positive gradient. It means when x increases, y would increase as well. Like the more hours we study, the more grades we will get, and so on. Here, we have down negative correlation. As you see, the line goes down. It has a negative gradient. So when x increases, y decreases. So this is negative correlation. But of course, correlations have different strength. So here, as you see, these data points fit very perfectly into a straight line. So this is a perfect, very strong correlation because the data fit very close to the line. Here, we have like a positive correlation, but as you see, the data points are not very close to the line, which makes it like moderate correlation, and here it's weak. Similarly here, but negative. Here negative, but very strong or perfect. Here moderate negative correlation, and so on. So how do we know if the correlation is strong or weak if we don't have these graphs or diagrams, or if we don't need to depend on our judgment like this is weak or not? Of course, we have a measurement for that. It's called Pearson's correlation coefficient R. It measures the strength of linear correlation between two variables. It's always between 1 and -1. When R is positive, it means you have positive correlation. When R is negative, you have negative correlation. And the closer R to 1, the stronger the correlation will be, but it will be positive. And similarly, the closer R to -1, then the stronger it will be, the stronger correlation will be, but it will be negative. So here, this is the strongest positive correlation. So here R will be 1, the highest value. Here it could be, for example, 0.8, like moderate or fairly strong. Here R could be, let's say, 0.6, like it's weak. Here R would be -1, perfect but negative. Here, let's say, -0.8, and here let's say 6 or 7. So as you see, the closer R to 1 or -1, the stronger the correlation will be. Now we will do here a full example to show everything in practice. Here, as you see, we have a table that represents the number of hours like a student studies, and here the exam score. And here we have the scatter diagram plotted for them. So here you see we have the point 582, which is this one here. As you see, 582 here. So now here it says, find the mean number of hours spent studying and the mean exam score. So in other words, they need the mean of these and also the mean of these. Now I know, of course, you can find the mean of these numbers. I think they are 12 numbers. Yeah, 1, 2, 3. They are, 12 numbers. So you need to add them up and then divide them by 12. Similarly for this, but of course, we can do it in a better way by inputting them into a list and then find the mean quickly. Because anyway, to answer question B, which is finding the equation of the line of best fit, we will also need to input them in a list. So now, I will show you how to do that in the GDC here. So first, to find the means, we need to input them in, now as you see, a list and spreadsheet. Here, you can label this better. It's optional, but it's better to do it. For the X, we will do the hours studied. So here I will write the hours. Of course, you can write them using this keyboard here. For the Y's, it will be the exam score, as you see. So here I will write the score. Here, as you see, for the X's, we'll input all of these numbers, and here for the Y's, we'll put these. So here we have 2, and then down here we have 4. Then after that, we have 6. So here now, we input all of these numbers, the X's and the Y's, the hours and the scores. After that, we will go, so now we are solving only question A, finding the mean of the number of hours and the mean of the exam score. So here we'll do now menu, statistics, and then you do stat calculations. Here, first we will do 2 variable statistics. We have here 2 variables, the hours and the exam score. Then for the X list, we will choose the hours, of course, as we named it. And for the Y, it will be the scores. Then here, as you see, the results will be in column, we'll make it column C, because we already input some numbers in column B. So here, as you see, the numbers, here, as you see, this X bar represents the mean values of X, which is exactly 4. Which means now the mean numbers of these will be 4. So here to do it, X bar, or the mean, will be 4. So this will be the mean number of hours. And similarly for the scores, the mean will be the Y bar value. Here it is, as you see, it is 77.1 to 3 significant figures. So now this is what we do about question A. For question B, they said find the equation of the line of best fit, or the regression line that fits into these points. So here to do it, we will use the same list we input here, the X and the Y list, the hours and the score. But this time, like, I would like to store the equation in column A. So we'll do now menu, statistics, then stat calculations. We will do linear regression mx plus b. For the X list, it will be hours. The Y list, it will be scores. If you didn't like name them hours and scores, you can just put A and B. Then we need to store in F, I think, or E, no problem. Let's keep it in F. So here, as you see, we have the information. This is the linear regression line mx plus b. As you see, m, or the gradient, is 5.42. So I will write now, the line would be y equals 5.42x. The gradient m is 5.42 multiplied by x, plus the y-intercept b is, as you see, 55.4 to 3 significant figures. So this is the regression line. And here also they said find the Pearson's correlation coefficient r, and it's already done, as you see here. This is r squared, by the way. If we scroll down, this is r, what we want, which is 0.966 to 3 significant figures. So for question C, r will be 0.966. Now here, in question D, it says, plot the mean point on your scatter diagram and use it to draw the line of best fit. So here, the mean point is this, which is what we found in A. So here, as you see, the mean point, we can write it like this. It's equal to 4 for X, 77.1 for Y. So it will be 77.1, which is nearly here. So this is the mean point. As you see, X is 4 and Y is 77.1. You can label it, of course. That will be better. So now here, is the point. Now, why did they tell us plot the mean point? Because you need to keep in mind that always any regression line must pass through the mean point. So now when we draw the line, we need to keep in mind that also the y-intercept is 55.4. Here, as you see, it's 60, so 55 would be a little bit like below, somewhere here. So if we draw it now, it will be like this. So this is the line of best fit. As you see, we pass through the mean point, and here the y-intercept is 55.4. So we write now 0, 55.4. Now, of course, in an exam situation, you would have a better y-axis to go through the y-intercept. I hope that you have found this explanation helpful. Please hit the like button and consider subscribing for more IB videos to come. Thank you for watching.